drawing short thing. So now I have a metal in slide into the USB port. And also like ship that I can then slide it. It's fine, it works for the most part, but occasionally when I click there's problems with plug outs, so just make it a new one. It's really funny because I can like put the metal thing in there and then take the chip.
It says like a tiny jaw structure.
Well, it's not like chewing on it, it's like
Like trying on.
yeah. And it's when you do the catnip, you start chewing on everything. Chew on the catnip like a container and the lid.
All right, let's get started. Welcome to Lecture 17, CSE 5323, 7323, Mobile Sensing and Learning. It is a rainy day today. It's a rainy Wednesday afternoon, which makes me feel like I'm at home. That's fine. So this is good. How's everyone doing today?
It's raining.
It's not raining? Okay. It's not raining at this exact second. I will give you that. Fair enough. All right. I left this slide in, so that's fine. Remember, I'm offering a class next semester. If you're interested in it, here it is. If you weren't here last time for UB Comp. It's a 7,000 level credit course. So if you're in a 4+1 program, I have had people take this for one of their essentially dual credit courses. So if you're interested, look it up or talk to me about it. Okay, course logistics. A4 grades. I doubt very highly that I'm going to be able to get A4 grades up this week. But probably I will try to do it over the weekend so that they're up next week. All right? A5 is due the Friday after this. So A5 has to do with microcontrollers and sensing. Essentially, everybody has an Arduino that's sitting inside there that they can mess around with. And there's a Bluetooth shield for every single Arduino that we have so that you can connect it to the phone using the methods that we talked about essentially on Monday for all the Bluetooth communication. And we went over everything that you need to complete that lab. So if there's any questions, let me know. And if you're sticking around for lab, I'll be around to answer questions for those as well. And get everything and make sure everything's set up on these Macs, right? Because you'll need to download the Arduino Sketch framework and everything and get them on the Mac. Good? So part of the requirements for A5 is that you have at least 2 sensors, right? One of them has to be analog. That's the only requirement. The other one could be digital, analog, binary. Doesn't matter what it is. Who needs sensors? Hey, Matt, where do you guys get sensors?
There's SparkFun. You can just order them, or you can go to Tanner's. It's like up kind of close to Addison, and they have a bunch of sensors you can just pick up. Radio Shack, I found to be less reliable. If you want something particular, like, they'll call like 100 stores, and then maybe one of them will have something.
What about Fry's?
I've never tried Fry's because whenever I go there to buy headphones, they're always like $20 more expensive than everything else. Places. So,
Fair enough. Is there a place on campus?
On campus to buy parts?
Yeah.
Go to the Innovation Gym and take them.
Go to the Innovation Gym and take them.
I mean, give them back eventually.
And give them back eventually.
Right.
Okay.
Like,
I did not say that. Matt said that, by the way. Yeah, you could always go down to the Innovation Gym. How many of you guys have been down there? Yay! So you can always go down to the Innovation Gym and be like, Greg, we need sensors. And be like, for, this guy Eric Larson's course is doing this thing. And then you might not want to mention my name. He may not give you the sensors. I don't know. We'll see. That's a joke.
Also, you can go ask Professor Fontenot for sensors from the freshman design lab. I'm sure he's more than anyone.
Anyway, so there's lots of different ways to get sensors. If by the end of lab tonight you cannot find a sensor, I will help you out to find a sensor to throw on your board. Actually, I've got a bag of them right here, so it's good. Okay? Happiness. Okay, good. So no one's going to send me an email Thursday before this is due and say, hey, I know you don't have any sensors, right? Awesome. Okay, the agenda for today, we're going to talk about Python. We're going to talk about the language of Python. Essentially, I'm going to talk about history and why I think you should know about Python. And then I'm going to give you, the rest of the course is going to be completely devoted to Python syntax. through examples. Okay? We're just going to go through. It's going to be essentially like when we talked about Objective-C, and I just started typing, and you guys said, what is that? Okay? Good. Moving on. Okay, Python. Python was created by a guy named Guido. Okay? Guido van Rossum. All right? It's already funny. Okay? Guido's a little quirky guy. He used to work at Google. This is him. Here's Guido. He's now over at Dropbox. But essentially, sometime in the very late 80s, and this is straight from Wikipedia, he says, over 6 years ago, this is in 1996 when he said this, over 6 years ago in December 1989, I was looking for a hobby programming project that could keep me occupied during the week around Christmas. My office would be closed, but I had my computer and not much else in my hands, so I decided to write an interpreter for a new scripting language I've been thinking about, a descendant of ABC that would appeal to Unix and C hackers. I chose Python as a working title for the project, being in a slightly irreverent mood and a big fan of Monty Python's Flying Circus. Okay, what you should get out of this, Python is an interpreter. It is a scripting language. It is widely used by hackers for lots of things and rapid prototyping. And it is based off of Monty Python's Flying Circus. Okay? It is not after the snake. Okay? Even though you'll see it everywhere. The snake everywhere. Python snake. It's not what it's named after. Okay? Python adoption. So, hold on. What do I mean by interpreter?
It's a line by line, so I'll read a line, interpret it, perform it, read the next line, interpret it, perform it. It doesn't compile code into assembly instructions.
Right. Quoi? Unless you compile it, right? Right? There are lots of code. There are lots of code. What else is an interpreter? Perl. MATLAB. All of these things you can compile them if you have a proper compiler, right? But most of the time they're meant for interpretation, right? That also means that you can open up like a terminal, type some things out, have it spit out commands, kind of in real time because it interprets that line by line, right? You don't have to have compiled code. Right? There are interpreter plugins for C#. You can turn C# language into an interpreted language. Okay? Has anybody ever messed with C#? I am a big fan of C#. I actually like C# a lot. You can stop execution in the middle of a compiled C# program, change the variables, write some new lines of code, and just hit run, and it keeps going. What? Amazing. Amazing. Okay? Anyway, we're going to keep moving. Okay, so the adoption of Python, right? It appears in just about every programming top 10 list. What do I mean by that? If you look and say Hacker News it's the #1 programming language in Hacker News, okay? Which is a survey that's spit out. All right? Well, maybe you don't like hacking. Maybe you're actually into using actual programming. You're not consider yourself a hacker. On the DICE job list, it's the #8 programming language that you need to know to get a job. Okay? For book sales, you want to write a book about Python, #8 in terms of all the programming languages that are out there. Okay? Maybe a very telling graph on why, looking at Python adoption is this graph right here. So if you graph the number of tags that are on Stack Overflow versus the number of GitHub projects, right, that use different code bases, and you graph them all around there, this is the graph that you get if you pick a bunch of different programming languages. If you look over here in the very, very top right, you're going to see stuff like C#, C++, Objective-C, Perl, Java and JavaScript, obviously. Oh, look, there's Python clustered right around Java and JavaScript. Okay? There it is. Over there by Ruby. Okay? It's used a lot. Right? Quoi? That's kind of funny. Right? I don't know. Is Lua in here? I don't see it. Is it really? Yeah. Hey, there it is. Look at that. All right. Look at it. So based on looking at this, you should probably know Python. Are you going to use Python in your career? I have no idea. After you use Python, you might. Okay? Some disclaimers about Python, right? I like Python a lot. It's not perfect. No programming language is perfect. All right? If you think so, you need to relook at it. All right. It uses weakly typed variables. It actually uses dynamically typed variables. What do I mean by that?
You can have a variable that's an integer, and then 5 seconds later, make it a string.
Yes. You can have a variable that is an integer, and 5 seconds later, 5 microseconds later, ooh, you can make it a string. Okay? Why? Because you don't declare it as an int or a float or whatever you want. You just use it. Okay? What are the downsides of that? What's the one biggest downside of not having a typed language that people will bring up over and over and over? Type safety. Like what?
So, if you're passing a variable into a method, you can't know that it's specifically what you want. Because they could pass in a string, and then you interpret that as an int, and it'll handle that, and you don't know
How? Right. Fair enough. Right? You can pass in a lot of different things. If it's not typed, you don't know exactly what you're getting. So another thing is that you can misspell your variable names, and that's fine. That's a new variable. You don't have to declare variables, right? Number one mistake that you'll have with Python is misspellings. All right, you'll misspell a variable name, and all of a sudden you're adding stuff to that, but it's not incrementing the variable that you think it should be incrementing so that you can exit the loop. Okay, number one mistake. Right? It's an interpreter, which also means since it's going line by line, it is not compiling loops into something optimized. It's going line by line through the loop, right? That means that that is slow. When you're going over loops in an interpreted language, it's slow.
So does it treat like every iteration of the loop like a whole new batch of
Brand new.
lines of code?
Yeah, exactly. It is like,
Through the loop, you could just change the loop functionality. So like if it's like looping through and it's got through half of the loops, then you just change what's in it, and then it keeps going.
yes, you can do that. All right? That's kind of tough to do that, but yeah, you can do that. Right? So it's slow until you compile it, and then it becomes fast. Okay? You can't use parallel instructions natively in Python. However, there's a huge community that's built around IPython, right? Which is like import IPython, and then you can use parallel instructions and threading and all sorts of stuff. Okay, very cool. All right, but it's not natively built in. All right, it's not part of the batteries included. Okay. It is more similar to Objective-C than you think, kinda. A lot of the things that we've looked at in Objective-C, you will see transfer over. A lot of the syntactic things that we've seen in Objective-C, you will use in Python as well. Okay?
Functions aren't brackets, are they?
Functions are not brackets.
So dumb.
It's not so dumb. Why is it not so dumb that your functions are in brackets?
It's not like a member of the actual class. It's just a message protocol.
Uh-huh.
You're just sending a message to an object, so it has to be in the message. It's not like part of that class's table.
Yes, and I would argue that it's more oriented around being object-oriented by you're sending a message to an object. You're not just calling a function which takes, maybe some objects. You're sending a message to an object that has very, very defined behavior, right? It's the most object-oriented I believe you can get and still have functions, okay? It can also be the glue for a lot of different code bases, okay? The first project that I ever did in Python was in 2008, 7, 6, I don't remember. It was something, so I was working over at Intel, and they had like 5 different code bases. They had some people that had written some they had some, not Objective-C code, some C# code, right? They had some OpenCV, C++ code. They had something that was doing something in Java and some JavaScript, and they were like, hey, we need to connect all of these together and do something important. We were like, great. So we used Python as the glue, right? We basically created little frameworks for everything so that Python was calling the actual code for Java, C++, C#, all of those objects. They were all inside of one Python script, and it was running, okay? So for rapid prototyping, Python is going to help you in that regard, okay? You can call native C++ and C# code from Python, right? I would struggle to think of a coding language that you couldn't compile and run from Python. Okay? Python releases. First Python was Python 1.0. There was actually a stable release, and that went up to version 1.6. Essentially, that looked the final version under 1.0 kind of very solidified basic Python, what basic Python was going to look like, all the different syntaxes that were there. It had built-in complex numbers, and it also used a lot of lambda expressions. Okay, you guys know what a lambda expression is? Yeah, for the most part. Yeah, it's a function defined at runtime. That's a pretty good definition, right? Right. It's very, very similar to the block coding that we do in terms of like its usage, the way that you would use a lambda in terms of block coding, right? We define this block, and then sometime later we're going to use it somewhere. We can define it at runtime. Okay. We'll get into what that looks like exactly. There's some syntax for doing lambdas. Lambdas are not. We'll talk about it. So 2.0, going up to version 2.7. This unified all of the types. They were basically in the background for Python. It also made the language completely object-oriented, okay? Right? So lots of class structures, lots of objects that things were inheriting from, right? And that went all the way up to 2.7. A lot of people still use Python 2.7 today, okay, including me. 3.0 was released. That went up to 3.4, which is the latest version that was released approximately 2 weeks ago. They were trying to essentially, with 3.0, they were trying to eliminate a lot of the paradigms that were in the original Python language. And they kind of succeeded, okay? The problem with going from 2.7 to 3.0 was a lot of things that you could do in 2.7 were broken now in 3.0. They essentially abandoned backwards compatibility so that they could try and fix the paradigms that they wanted to fix in the language. Okay, so that's why you still have a lot of people that are still using 2.7. That's why you still have a lot of people that are building frameworks for both Python 2.7 and 3. Whatever the latest is. Okay? So in this class, I'm going to use 2.7. Right? I like it. Installation. Okay, so when you want to install Python, I want you to open a terminal, and I want you to do nothing. Okay, OS 10 ships with Python 2.7 and 3.0. Okay, or 3.3. Okay, it comes with the OS. You're good to go. But you are going to want access to different packages of Python. If you're running from a Windows machine, just download Python. It's super easy. Okay. You're going to want access to the packages. The way that you get access to these packages is through essentially third-party. So I use something. You're going to want to use something like MacPorts. I like MacPorts. So if you download it from http.macports.org, if you're using Windows, you might want to use pip. Right? It's essentially, it allows you to install any Python package that they have in their library of all the different Python packages that people update. Right? So you can you open up a terminal and say sudo port install some package. Maybe it's NumPy. Right? So I want to install NumPy package. Sudo port install NumPy, and it will download and make it available for you. Okay? So that now when you need to use that framework, you say import framework and you're done. It's ready to go. Python. Okay, let's do a hello world. Very, very quickly. Okay? But it's going to be more than just a hello world because I want to show you some of the semantics for scripting and an interpreter. How many people have looked at Python before? Wait a minute. This is very, very different than Monday. Okay, fair enough. That's fine. Okay, so if I wanted to do hello world, somebody tell me how to do hello world. Here, how about I do that? Let me open up a terminal first. Tell me how to do hello world from here. Python 2.7 in my terminal. Oh, I'm in Python 2.7. Hello world. Print space quotes hello world. Hello world. Boom, we did it. Okay, Control D, I exited out of that. Here I am in my untitled thing here. I want to do hello world again from here. Okay, so that was using this little scripting right here, right? Sorry, my interpreter. right? I opened up a terminal, typed Python 2.7 in, and I could live interpret what's going on. I could also do it from here. Does anybody use this type of editor called Sublime Text? I love Sublime Text, right? And for Python interpretation, really, really good. Okay? I think it's much better than Xcode. Don't use Xcode. Don't use Xcode for Python. It'll screw up all your indentations, which is really important in Python. Okay? So let's do this. Print. I'll do double quotes. Hello with 2 L's world. Okay? And that's going to print hello world. Okay? So let me save this. Let's save it to the desktop. I'm going to call it hello world dot py. Py. Ah, look. Print hello world. Sublime Text realized that I was typing in Python right here, and we got something good to go. So now if, what am I on there? No. Change directory to the desktop. So now I could say Python 2.7. Oh, come on. 2.7. Can you guys see that? Is that big enough? I increased the font on it. Hello world.py. Oh, hello world. Okay. Any questions on interpreting versus opening up the console?
Could you make the font bigger?
Yes. Terminal. Preferences. Change. 18. Yeah. How's that? Good? We can make this one bigger too. All right. Here we go. So that was Python Hello World. Maybe the best Hello World that you've ever seen in your entire lives. Okay. Python. There's lots of different coding styles that you can do with Python. The best styles for coding in Python get the distinction of being Pythonic. Okay? Wonderful little world, wonderful little quirky thing. It's an ill-formed definition of what is considered Pythonic code and what is not considered Pythonic. Because really, Python is changing as people are looking at the code base and looking at examples that people have used and writing their own frameworks. And so as the language changes, the definition of Pythonic also changes. That doesn't mean that Pythonic is not a good thing to strive for. It just means that it's kind of hard to define. Okay? So is machine learning. Pythonic code is simple and readable. It uses dynamic typing when possible. And when not possible, when it's better to use the strong typed, it uses those. Okay?
So you do have
You can type things, absolutely. Or, to quote someone named Tim Peters, if you type import this in the Python terminal, this will spit out right here. It says, this is essentially a definition of what is Pythonic. Beautiful is better than ugly, explicit is better than implicit, simple is better than complex. You can go through line by line and look at these. None of these are strict, hard and fast rules that you have to follow. They are design critiques that you have to interpret. Okay? So you can go ahead and look at this when you want to take a look at it. Okay, Python is quirky. I will be the first one to admit that. Don't assume that this means that Python isn't a serious tool, okay? Because it is. But the naming conventions are kind of funny, okay? C++, that used to be funny as well, okay? Why? Why was C++ a funny name? It was an increment of C, right? The coding languages before that were A, B, and then there was C. Well, yeah, okay. But after C, they were like, we're going to build on C. We don't want to be D or E. We want to be C++. That's funny. You guys don't think that's funny, but it is, okay? Okay, syntax. Numbers in Python are ints and floats, and they also have native support for complex numbers. So if you were to open up an interpreter and you were to type 7 times 5, it's going to look at that. It's going to see on the fly, it's going to try and figure out the number that you typed. Is that an int or is that a float? Okay? The same thing happens in your C languages, right? So what is this? What is 7 times 5 in this line that I have right here? What? It is. It's 35, right? It doesn't matter if those are ints or floats. That's 35. What's 5 divided by 7? Something less pretty. Well, if you type 5 divided by 7, you're going to get 0. Because that is an int divided by an int. Floor. 0. Okay? 7 divided by 5. 1. 7.0 divided by 5. 1.4. Is that right? Yeah, okay. Right? So if you look at that very, very last thing right here, this is a float divided by what could have been an int, right? But it took care of all of this kind of typecasting for you. It was like, yeah, you meant float. I'm going to cast this as a float. Okay? And it gave you 1.4. So the answer was a float. Okay? So let's say we want to define a variable. So my temporary variable, by the way, so I'm using Objective-C for my naming conventions on the variables, right? Lowercase and then capital, da, da, da. If you want to be strict, if you want to be Pythonic, the way to do this would have been temp_var, all lowercase. Okay? That would have been the Pythonic way of doing things. All right? What's up?
He always yells at me for using underscores.
Well, don't do it in iOS. All right? But I'm way too used to it. I keep doing it. Okay? I'm too used to it when I was putting this. I can't remember when I put this together, but so if I print temporary variable, it's 4. What is the type of temporary variable? Int probably. Yeah, it's an int. Okay? So if I were to type tempvar over 8, I'm going to get 0. Tempvar divided by 8.0, same kind of thing. If I have an int divided by a double, bam, I'm going to get 1/2. Okay? Right? So I think this kind of shows you this is enough that we can kind of figure out how typing works in Python. Yeah? Right.
Does it ever, for any reason, store numbers as a string if you aren't telling it to?
Does it ever store numbers as a string if you're not telling it to? I can't think of a situation offhand where that would happen. That's not to say it doesn't happen. It uses J instead of I for complex. Okay? Yes, it is the electrical engineering convention, not the physics convention. Okay? All right? Python was probably written by people who applied their knowledge. Okay? Oh, I'm sorry. That was a joke. It was just a joke. All right. So, yes.
Is there any type of, like, for example, the semicolon to end instructions, or how would you...
You can put a semicolon there. It doesn't do anything. It makes you feel better. Python's like, cool, semicolon. All right?
What if you do, like, multiple lines? What if you interpret each as different instructions?
So not Pythonic.
You can do multiple lines. Pythonic code, if your code goes above 79 characters long, go to the next line. Okay? And you put a little slash. You can put a little slash to say that you're going to the next line. Okay?
That's how you...
Backslash. Okay? All right. And I think there's some conventions for using white space too. When it'll go to the next line when it needs to. Now use the backslash to make it explicit. Okay. So if I were to type 1 plus 1j right there, where I have the number in front of j, right? So 1j it knows is not a number because you can't have a variable that starts with a number. All right. Right. So I type 1j. That's a complex number. 1 plus 1j. Okay. If I were to type 1 plus 1j times 5, what is that? 5 plus 5j. Bam. Look at this. Look at you guys using the distributive property. All right. 1 plus 1j plus 4. 5 plus 1j. All right. Here we go. So those are complex numbers. They're natively supported. You can take the absolute value of 1 plus 1j, which would be? Yeah, square root of 2. All right. Good. Strings in Python. Strings that you make in Python are immutable. Okay? That means you cannot change them once you have them. Okay? But it's a weakly, dynamically typed language. You can just add different strings together, create a new string, right? And save it back to even the same variable name that you were using before. Okay? So yeah, it's immutable, but it's not as big of a deal as when other languages that are typed. Okay? What do I mean by this? Let's take a look. Okay, so I can define a string that's in single quotes. There, that's a single quote string that will be defined like this if I were to put that in the interpreter. Okay, single quotes. I can define a string in double quotes. And it will be like, oh, look, it's a double quotes. There's your string. I can define a string using both single and double quotes. When I do this, I start it with a single quote. I say, here is double quotes. In double quotes, my double quotes are part of the string. Okay? What if I reverse that? Oh, sorry. What if I want to have single quotes, but I'm defining it in single quotes? I have to escape it, right? So I put a little escape in front of the single quote. So now I'll get that. Okay? And Python, when it prints it out, it's going to use double quotes because I'm only using single quotes on the inside. So it's a little more clear that the single quotes are part of the string. Okay? Here's also double quotes. I can do double quotes the same way with an escape character. And when it prints it out, it's going to reverse things for me to try and make it prettier. Okay? A little more easier to look at and understand. Okay. I'm going to define a string. Let's say I define some string and I call it mobile sensing and learning. Okay? Well, if I were to do this command right here, so the way that you index into a string is with kind of braces. Okay? So if I say some string colon 5, this is going to print out what? The beginning of the string up until 5. Right? So everything up to 5.
And it doesn't start at 0.
Is 0 indexed. It is 0 indexed.
So it doesn't include.
So it does not include 5. However, if I were to type this, some string 5 colon, instead of colon 5, then from 5 to the end, E, sensing and learning, right? So if you were to kind of go through, so if, you know, it's this neat little thing that they do. If you type some string colon 5 plus some string 5 colon, that gives you the original string back. Okay, plus concatenates the strings.
So on the front end, it is not included. On the back end, it does.
Yes, it's still 0 indexed, all right? If you're used to MATLAB, get over it. It's 0 indexed. All right, so if I were to say some string plus and control, I would get mobile sensing and learning and control. All is one string. Okay, concatenated. If I were to say some string times 3, I can do that. That's valid. I'm going to get this. I'm going to get that string repeated 3 times. Okay?
Wait,
Because it adds it 3 times.
when you added and control to it, it stuck right. You reverted back between these two. Like,
I didn't save that.
Okay, if you
I printed that. Right? It spit that out, but I didn't say some string equals some string plus control. Right? Some string -5 colon. Yeah, it's going to print out the last 5 characters of that string.
So since it's like a ring array type thing.
Yeah, yeah. Except if you were to type some string colon 1,000,000, it would still just print out one string. It would print out the string if you said 1,000,000 right there, because it just keeps going over and over, and it's like, bam, okay, here, we got the string, I'm going to print out what's left. However, if you were to say -1,000,000 colon, you would get an error. You can't do that going backwards. You can only go backwards up to the length of the string.
Why didn't they just make that default to begin with?
Maybe they will in 3.5. Maybe they won't. Okay? If I were to do this, where it's some string colon -5, that's going to say print out everything except the last 5 characters. And I can also do these things. Probably should have done these first. Some string at the 5 is an E, right? So it is 0 indexed, right? Some string at the -1, it's G. It's the very last character. Something at the -2, an N, blah, blah, blah. You can keep going, okay?
So backwards, it's not.
Well, if you were to say some string at the -0, what's -0? 0. It will still give you the 0th element. -0 and 0 will give you the same element, the 0th element. Okay? The best way to think about it is if you've got a string and it's these blocks, right? And the very first block you have a 0, a 1, a 2, a 3. right? So if you wanted things up to 5, it's going to go 0 up to this 5th index, but not including the 5th, if you look at the blocks. Okay? I think that's probably their, look on their python.org, and they will give you tutorials on all of this as well. Okay? I didn't mean to do that. What if I were to do some string at the 5 equals r?
I would have guessed that it would replace that character with R. But I just saw an error, so I guess I'm gonna get
It's immutable. So I cannot do this operation, right? It does not allow me to change things in that string. That's why I get a traceback error. String object does not support item assignment. Okay?
So you just make a new string that has.
Yeah. Yep. Yep. Okay. So, that is strings. Tuples. How many, you guys work with tuples in other languages? Probably. Yeah. In MATLAB, right? There are some MATLAB Python comparative things in the languages, right? They're both interpreted, and there's a lot of people that write in both communities and contribute to both communities. There's also a lot of people in Java and JavaScript and Perl and stuff that are in the Python community, right? So they take the MATLAB users and they say, we're 0 indexed, okay? I know what's wrong with you. Anyway, it's one of my pet peeves. People in MATLAB, 1 indexed? What? Anyway, I'm sorry. Okay, so if I were to define a variable, I'm going to say a tuple, right? It should be a underscore tuple, but I wrote a tuple, right? A tuple equals 45, 67, and a string called not a number. If I were to type that in, it gives me a tuple of 45, 67, and not a number. Okay? What? You can do that. It's fine. That's a tuple. Okay? Tuples are immutable, which means you create a tuple, you cannot change it after that. Okay? That is a big downside. So most people don't really use the tuple part of Python, except for certain conventions, right? Normally what you want to do is you're creating a tuple, it's going to be something you're changing later on. That means you need a list, not a tuple. Okay? A list is highly versatile, it's mutable in any way that you can think of, right? Which means you can use it as a linked list, a stack, and a queue. And it's a container for anything. Okay? So what do I mean by that? If I want to define a list, I'm going to use my open brackets to define a list. Okay? Right? In the same way that you would do this. Well, yeah, it's not exactly like MATLAB, actually. MATLAB, you define a cell array with just char. Anyway. So a list, I would declare this is a string right here. This is the first element. Here's the 0th. Here's the first element here, 5.0. Then I've got 6, which is an int. And then the last element is another list of 432. Okay? This is very, very similar to arrays in Objective-C.
Can you do like matrix operations on these like you would be able to in MATLAB or?
You can, but you have to use NumPy.
Okay.
And we'll talk about NumPy next time. Or 2 lectures from now.
How do you access elements inside the list?
Okay, so if I were to print this out, I will get to that in 2 seconds. This is what I would get. It defined this for me, right? So I print it out. Print a list. If I want to say a list at the 0, bam, I get a string, right? So I've accessed that memory there. Answer your question?
No, the ones inside. So 0, 0 would return 4. 0, 1. Yeah, how do you access 4, 0, 2?
How would you do it?
Just another bracket number, but
That would work. So I could say a list at the -1 at the 0, and that would give me the number 4. So go to the last element in my list, and then go to the 0th element inside of that.
Can you make multi-dimensional lists?
Matrices? Yes.
Images?
Yes, you can.
And then how do you differentiate between that? Like how do you differentiate between accessing the elements inside a list that's inside a list and accessing one in the next column?
All right. So if it's a matrix that you're accessing, it's going to be a bracket, number, comma, number, and then the end bracket, right?
Oh,
So
okay.
like you're actually going into a matrix. If you're accessing a list within a list, right? Then it's 0. You're going to say, okay, I want the 0th element, then another open bracket, right? So you're accessing into that, right? So that's a nested list. Okay, if I say A list at the 2, I get 6. If I say A list at the -1, I get that list, right? So I could have said A list -1, 0, and that would have spit out 4 right here. Or if I said -1, 1, that would spit out 3. Okay. There are built-in operations such as length. So if I say len, L-E-N, open parentheses, A list, I get 4. It means it's 4 long. Okay? Most of the operations that we did with strings still hold right here. So if I were to say the length of A list at the -1, what would that give me? 3. Why? Because the length of the smaller list is 3. Awesome. Everyone's paying attention. Moving on. Okay, so if I were to say A list from 0 to 1 equals empty.
Not immutable.
That's right. Well, yeah, it is mutable. Don't say it's not immutable.
Yeah.
It is mutable, right? It's mutable. So if I were to print this out, I would have gotten rid of the 0th element with that. So 0 to 1, not including 1. Right?
So there's no like null character or anything.
There is. It's called none.
But it didn't, how would you fill those first two with none to just clear them?
Well, a list is a little bit different.
Oh, okay.
Right? Because when a list, you want to empty out, essentially. I could have also done a list dot remove 0. And it would have removed the 0th element. Okay.
So it is more like a queue or something.
You can use it as a queue. You can also use it as a stack. We'll talk about it. Okay, so if I were to say now that I've manipulated A list to be only these 3 elements long, I could say A list from 0 to 2 equals nothing. What would I get?
Just 4, 3, 2 within double.
Yeah. It is a nested list now of 1 element. Right? A 1 element that points to this other list. Bam. Good. Okay, so now if I say another list equals empty, I'm going to say I equals 0. I is a integer. I plus equals 1. That works. I plus plus, not works. Okay? So if I were to print out I, it's equal to 1.
Can you say I equals I plus plus? Or just the plus plus operator?
Plus plus operator not used. No good. So now, let's say I create a while loop. Okay? Well, there's a little bit of new syntax here, don't worry. While I is less than 1,000, colon, another list dot append I. What was that going to do? Yeah, it's going to add I into the list. It's going to append it onto the end. Okay? Then I'm going to say I plus equals I. What's going to happen if I were to print this out at the end of that while loop? Bam. 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 56, 5, 12, and then it stops because it's greater than 1,000.
How would you write out that while statement in an interpreter in like 1 line?
In an interpreter, but in like 1 line?
Yeah. Well, I assume to do a loop you have to have it as 1 line, or else if it's doing a line-by-line interpretation, how does it? Or does it just wait?
Ah, that's a very great question. Let's talk about that. For and while loops, indentation matters. Actually, indentation is the only thing that matters. Okay? So if I were to write a while loop, like I did before, it would need to look like this. I equals 0, while I is less than or equal to 10, or sorry, is less than 10. Open this colon, here's the loop that follows. Anything that's now indented, and it's tradition to use 4 spaces, to be Pythonic, use 4 spaces, not a tab, 4 spaces. Okay? If you're using Sublime Text, it will automatically interpret a tab as 4 spaces and insert that for you. Okay? I'm going to say print, I'm going to call this function called string. So I'm going to turn I into a string, and then I'm going to concatenate that with is less than 10 and print it out. Okay? So a while loop, not much different than anything you've probably ever seen before in another language. Okay? Except when I do this. What? A while loop? Yeah, it has an else statement that I can or cannot put with it. I don't have to put it there, but you can have an else statement.
Does the else only happen the last time? while?
The else only happens when that conditional is not true and you're about to exit.
Can you do else while?
You mean a do while loop?
No, I have like while, and then once that while ends, it'll do the else, but that else
Is another while loop? Yeah, absolutely.
Just put the while inside the else.
Yeah, you just put the while inside the else.
Yeah. So like if you have a nested loop, you keep indenting. Right? So if I got a nested loop, if I indent 4 spaces, 8 spaces, that code is now part of that indented loop until it reaches a line of code that's not indented and it exits out.
I'm confused
Yeah.
what the point is of the else, because can't you just put that print stri is not less than 10 as the very next thing and it'll execute because you just got out of the loop?
You can, except when you exit the while loop on a break statement. When you exit the while loop on a break statement, the else will not be called.
Ah.
All right? Fair enough? Good.
Wait, so it will not, when you execute break, it will not execute the else.
It won't yeah. The else statement is when that conditional ceases to be true. That's keeping the while loop running. When you say a break statement, that conditional still might be true. Right? And then it will exit out. It only does it when it gets back to the while loop and it says this is false, else do this, and then keep going. Okay?
So once it's done with all the loop logic.
Right. Okay, so this would print out this right here. Blah, 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 blah. 10 is not less than 10 when it gets to the very end. Okay? Excellent. A for loop. Okay, so here's my for loop. I'm going to create this little array called class teams, right? And it's got the team names. Here's team, here's team monkey, here's team CHC, here's team, that guy in the back, and the number 42. Okay? For, I'm going to say team in class teams, print teams, team times 4. Okay? Else print ended the for loop without a break statement. All right? When I execute this line of code, this for loop is going to occur for every single element inside of class teams. All right? So it would print out this. String times 4, repeat it 4 times. Question? Why are you raising your hand? Yeah.
So what if one of the elements of class teams was another list, right? Could you make your for loop go through the list, and then if the element in the list is a list, go through the elements in that list?
Yes.
You can.
With another for loop. Right? And you would use essentially introspection. You're like, if, this is whatever class you're looking for is a list, then loop through it. Okay? Right? So this else statement only gets done at the very end when you've exited that for loop without a break statement. Same way as the while. Okay? Good. All right. So the for loops that you have are very different than probably a lot of the other languages. They're much more similar to a for each statement because there really is no native for loop in Python. Right? It's for each element in this. Right? So when I say something like the range of 10, that is a function that returns the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? It creates a list. Right? So when I say for I in the range of 10, that's for I equals 0 to 9. Okay? And it does it by creating a list. Right? So when I print out I, I'll get that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? I can also, the range statement can take more than one argument. I could say I want range, so for j in the range of 2 to 10, go by 2.
It's not Pythonic. Thought I'd point that out.
This is not Pythonic.
Well, you don't have the correct number of spaces for the print.
You're right. You're right.
Yeah,
That
was
is-
even more.
That's not Python. I don't know how that happened. I know how it happened. I was trying to copy and paste the keynote, and it messed up my tabs. It would print 2, 4, 6, 8. Okay? That's a for loop. That's all you need to know about for loops. Data structures. All right, data structures in Python. Lists can be used as a stack, right? So we already saw, this dot append notation for lists. So if I take back my class teams to be all of this that I have in here, I can see class teams.pop. All right, class teams.pop will give me 42, the element at the end of the list. And now class teams, 42 is gone from that list. All right, it popped it off. It's a true pop. All right. Class teams.pop again will give me that guy in the back. All right. I'm not talking about you, by the way. Class teams.sort. That'll give me that now. CHC monkey team. You can also import the queues libraries. You can say from collections import DQ, and it'll give you access to call these things like pop left, right? So you can essentially do first in, first out. Yeah.
How does it sort elements? Like if you have nested lists or numbers?
Yeah. That's a fun one. It's not very Pythonic to sort something when the elements are not all the same. You can, but it's not very Pythonic, right? Because you can still do things like is some string greater than 7? That's valid, and it will go ahead and try and evaluate that. What that is, I have to look it up every time. I have no idea. Can't remember. That doesn't make any sense, right? But it will sort them based on that, based on the conditionals.
Is it Pythonic to have lists of different types of elements?
That's okay. But if you're sorting them, it's not clear what you're doing, right? Pythonic is also, I could tell you a definition of Pythonic and we could argue about it. So if you were to go to a conference that, I don't know, a bunch of Python developers went to, and you were to try to define what is and what is not Pythonic, you would be where we are today, where you can't do it, all right? Because they just argue with each other. All right, but there are some conventions that they did come up with, right? Simple. Question?
Yeah, it's kind of related, but even if you have all the same elements and those are complex numbers, will it, and you do sort, will it sort by magnitude or like?
Oh, that's a really good question. Probably by magnitude.
Because that seems like it would be one useful thing.
I would think it would sort it by magnitude.
So is there no way to, I mean, I'm sure there's a library out there, but you can't just like make like a stack data structure. Like a list implemented to behave like a stack is still different than a true stack.
Than a true stack.
Right.
I would agree with that. Right. You can create your own stuff if you wanted to. Like you can create your own class, which is a stack.
But there's no like default stack.
There's probably inside of Python collections. But most of the time, I mean, you can, if it's used as a stack, like if it looks like a stack and acts like a stack, but underneath it's really not a stack, well, it might as well be a stack in Python, unless it's less efficient, right?
Seems like a list. If you're using a list object, that would waste time.
I agree.
If you compiled it, would it optimize it to be a stack if it saw that it was behaving like a stack?
These are great questions that I'm not going to be able to answer. Yeah.
How do you comment things? Like, when you
Pound sign.
pound sign?
Okay.
Multi-line too?
For multiple lines, single quote, single quote, single quote. And then the next time that it sees single quote, single quote, single quote, that's the end. All right. So dictionaries. You can define a dictionary like this. My dictionary is Team A 45, Team B 77. Very, very similar to the way Objective-C defines dictionaries, right? Okay? So Team A is the key, and here's the value, which is 45. Okay? Good? Happiness? Now if I were to say my dictionary at the Team A, I would get 45 back. All right? Excellent. Comprehensions. This will be a little bit different than what you've seen in other programming languages. So comprehensions are something you can do which they essentially operate on a list, right? So if I were to say this variable times 4, and I were to say open bracket x times x times x times x for x in the range of 10, essentially what that is telling it to do is, hey, give me a new list, and for this element in the range of 10, do this operation. Multiply it 4 times. And return it and put all of those into one list. Okay? This is very, very similar to like a lambda expression. Okay? This is considered a little more Pythonic because it's a little more readable. Right? Like if you were looking at this, I'm going to say, okay, this is x to the 4th for x from 0 to 9, right? Times 4, you print it out, and it gives you all of those from 0 to 9, everything to the 4th power, right? I should have said 4th power here instead of times 4, but whatever. Okay?
Wait, why did it go up? Oh, it did 10.
Yeah, so I got 0 up to 9, the range of 10, okay? Now I'm going to call this right here. So from random, import randint. Okay, random is a framework in Python. If I want to import randint, which is some method that's in there, this line of code does that. Okay, I also could have said import random. And then I could have called the function random.randint. Okay? So I use randint down here, where I say randint 0 to 4. Right? Give me a random integer between 0 and 4. Okay? So I set this thing called grades. Grades equals A, B, C, D, and F. Right? And then I say team grades equals for T in the range of 8. There are 8 teams in the class. Right? So for each of those teams, assign a random grade.
This is not how you're doing it.
This is not how I'm grading you guys. No. No, I'm like, maybe it is, just a little bit, right? No, I'm just kidding. So if I were to print the grades, I would get this, C-A-F-A-C-A-D, right? I would get 8 of these elements, randomly drawing from this other list, okay? This right here, not so Pythonic. It's not all that easy to just kind of go thin, right? Maybe it's a little bit better to write this as a for loop, right? When I'm randomly assigning something from it. Kind of 6 of one, half dozen of the other. You could argue either way. Those comprehensions, they can be nested as much as you want. You can nest things. So I could say, you know, like x to the 4th for x in the range of 0 to 10 for y in the range of, you know, 5 to 7 for da-da-da-da. I could just keep nesting for loops, right? Okay, when you're doing more than about 2, you start to lose a lot of the simplicity that's there. Right? But essentially, it would be a nested for loop. Okay? It's only Pythonic if it makes the code more readable. So it's up to you. You can also do this. You can use comprehensions with dictionaries. So right here, I said times 4, and essentially I gave it the key that I want to be returned and the value of that key. Right? So x colon this for x in the range of 10. And now when I print out that, it's returned a dictionary, right? Where 0 is the key, and then this is the value, and then 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, da 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 da. Okay?
Can you easily access those values by the key?
Yes, absolutely. And if those keys were strings, I could just put that key as whatever it is to get into there, into the dictionary. Yes, absolutely. All right. So now I could say, okay, from random, import randint. Now I'm going to say, here's the teams. I've got CHC team, got doer king, dorking. I got much code for etc. I've got all the teams in the class. Okay. And now I would say, okay, grades A, B, C, D, and F. Well, and then I were to say, okay, team grades equals, I'm going to have the team, and then I'm going to have grades with as a random int right here. What would I get back? All F's. Let's see. Okay, team etc. got an F, and then everybody else got an A and a B. Look at that. Oh, that's perfect. This is like the greatest Python code ever. I had to manipulate this, okay? It was trying to give everybody like a C. So I went in and gave everybody A's and B's, okay? But I tried to make it random. This has no bearing on your actual team name, okay? This is just a Python. Okay, pop quiz. I want to add the numbers from 0 to 100, not including the number 100. And I want to do it in Python. How do I do it? What did you just say?
Because you can use an iterator, right?
Or you just say range 100.
Okay, so okay, wait. What if I did this?
Oh.
What if I did this? What if I did this? I said some value equals 0. For I in the range of 100, some value plus equals I. This would work, and I could print some value.
I think you could be more Python.
I think it could be more Pythonic too.
Yeah, just print. Like start with print.
Uh-huh.
And just like put everything there.
How about this?
Yeah.
Range 100. Yeah.
Whoa! Absolutely. Print the sum of range 100. Okay? What if I did this? Use real math. There's a formula for this, right? Or I can just do this in a few multiplications and a division. Done. All right? Go Sir Isaac Newton. Okay, now what I want you to do, I want you to print the index and the value of every single element that's in a list. How do I do it? Print list. No. I want you to go through the element and then print them out in a loop.
For I and list, print I.
For I in list. Okay, so here's my list. So for I in the range of the len of list, print, turn whatever is in the list at I into a string, is at index string at I.
So concatenating integers to a string, you have to.
Well, I want it to be a string. Yes. I could have just said comma right there, and it would have just printed out I rather than making it a string and then creating a string. Right? Because why am I doing this? Why am I saying for I in the range of the length of the list?
So you get the index.
Yeah, I want to be able to print out the index, right? Is there a more Pythonic way of doing this?
I thought that you answered that question.
What?
I was saying, like, why can't we just say is at index?
Oh, you can, but you would say is at index, comma, I.
Oh, okay.
And what it would do is it would print out the string, and then it would go to the next thing in the tuple. And I put a comma there. I've created a tuple, and it would go and it would print out I, the integer value of it, or the float value, whatever it is. Here, I'm just explicitly converting it to a string and just making one variable.
For I in list print the print list dot index of I, then your is that index of I.
I'm going to make this easier on you guys, right? I'm going to use a different function that I haven't told you about before. For I, an element in enumerate list, print string at the element is an index string I. Okay? So this enumerate function will return each of the list and the index that an element is at the end. Okay? This is the most Pythonic way to do that. This is a Pythonic way to do that. I don't know that it's the most Pythonic.
Put it in a Python form and have
So that gives you a dictionary with the keys being the indices?
Well, not exactly. It's not a dictionary. It is a tuple. It will give you back a tuple each time a new tuple in the for loop. Right? Because you can actually do assignment with tuples. Right? I could say I, j, k equals 1, 2, 3. That's perfectly valid Python syntax. And then I is 1, j is 2, k is 3. Right? So what this element is doing is enumerate list gives me back a tuple of I element. Okay? Good? All right. So this is what I would get out from either of those. Okay. Pop quiz over. Conditionals. Okay. We're going to use the keywords if, elif, else, none, is, or, and, not, equals, equals. You can also use exclamation point equals. Okay? So, if I were to say this, A equals 5, B equals 5. If A equals B, print everybody is a 5. Else, print wish we had a 5. Or wish we had 5s. Okay? If I were to do this, what would print out? Everybody is a 5. We're good. Awesome, right? Equals equals checks for equality. Okay? A equals 32,7676. B equals A. If A is B, print these are the same object. Else print wish we had the same object. Okay? Is checks for identity. All right? They are the same memory location. Yeah. So what would this print out?
Wish we had the same.
Would it?
These are the same objects.
These are the same objects.
Oh, because it's just
Because B equals A. I did that in the assignment, right? So B equals A, these are the same object.
So those are pointing to the same memory location, not making a new copy and putting it in B.
Yes. Those are
How do I make B equals copy of A?
B equals copy of A. You would say B equals A dot copy, I think. Or you might need to use a tag keyword like I think there is a copy function that you would do for it. I don't know. If it's a class, you may need to do a deep copy, right? But
So is all your memory manipulation implicit? Like you can't specifically say, you know,
for the most part, yeah. Yeah.
If you modify B, would you modify the value of A?
Nope.
How does that happen?
But you just said
I know. It's not a pointer. It's saying do they have the same memory location? If I were to right after this say B equals 5, B would equal 5, A would equal 327,676. Okay?
So
It changes the variable of B. Yeah. Yeah. It's a little weird.
So
Then it would be different.
what if you said B equals 327676? Would it recognize that it had already put that somewhere else in memory and then make that the same memory location? Or would it use separate memory locations?
Let's find out. Let's say that I said A equals 327,676. B equals 327,675 plus 1.
Oh man.
If A equals B, print these are the same object. What do you guys think is going to happen?
I think it'd be Pythonic to use the same memory address.
Wish we had the same objects.
but it's not fair. So if you change B,
Mhm.
it makes a copy of the value, and now it assigns a different memory location for B.
Mhm.
Automatically.
If you didn't have the +1 and you just had the exact same number, it wouldn't make a difference, right?
That's right.
And what if you wanted to do?
Well, okay. It should be that is correct, what you just said. Do I want to do this? I don't want to confuse you guys.
Does it depend on whether you compiled it or line by line it?
No, it doesn't. It depends on how Python cached it. So let me, okay. So what if I were to do this? A equals 5, B equals 4 plus 1. If A equals B, everybody is a 5, or wish we had 5s. What's going to happen here? Wish we had 5s, right? Is what should happen. But you're going to get everybody as a 5. Why are you going to get everybody as a 5? Because for small integers and strings, Python, when these two things have the same value, it just caches it into the same memory location, right? Until it needs to change it. Okay? So small integers are cached at this point.
What is
What?
That's the question.
What is a small integer? Probably less than 32. Maybe less than 1,000. I don't really know. Maybe it depends on...
I guess they kind of have to tell you that because otherwise
Just iterate through numbers until it changes.
Yeah. Anyway, this is the most confusing that Python will get with these conditionals, is the difference between is and equality, okay? The way to get around this, try not to depend on looking at if things are in the same memory location. Okay, maybe even though you might waste a little bit of memory, it's probably a little more Pythonic to make it more readable. Yep.
In the first one, when you said B equals A,
Mhm.
I was thinking, what if you actually wanted B? Well, right there it's the same. B is equal to the same memory location.
Yep.
What if you actually wanted to change that memory location value? Is there any way to refer to that memory location?
Yeah, A.
Just A.
The variable A, right? Like these are variables and they're dynamically typed. And these are some of the issues that come up with dynamic typing, really. Okay? Learn to love it or hate it. And then keep going. Okay. Let's do some more conditionals. So I'm going to say teacher equals Eric. I'm going to say if teacher is not Eric with a capital E, print go get the prof for this class. Otherwise, print welcome professor. What would happen here? Go get the professor, right? Why? Because of the capital E, right? Okay, wonderful. Now, let's say teachers equals Eric, Paul, Ringo, and John. Okay? If Eric not in teachers, right? So now I'm looking at comparing this into an array. Go get the prof for this class. If I were to do this, it would say welcome, right? Because Eric is in that list. Okay? You can also do, when you want to do an and statement, don't use ampersand, ampersand. Okay? You're going to say and. You're going to spell it out, right? Very readable language. So this would say, let's say I've got these things right here. I've got should check for teacher. That equals a Boolean, equals true. And then if Eric not in teachers and should check for teacher, print go get the prof for the class. If should check for teacher, print welcome professor. Else print not checking. Okay? Welcome. Good? Conditionals? Pretty boring stuff. All right. Functions.
Is or the same thing?
Or. O-R. Yeah. And you still use parentheses to kind of define logic, how you normally would with binary logic. Yeah? Okay. So, the def keyword. Essentially, that is define, right? So you will define a function with def. All right? So essentially, if I create this function called show data, right? Now I'm being a little more Pythonic, right? So def show data, and it takes the input data, and then I'm going to print whatever this is on the input, right? So data. So I'm going to say sum data equals 1, 2, 3, 4, 5. Show data, sum data. Okay? This has to be defined before I use the function, just so I can see. Okay? It would print 1, 2, 3, 4, 5. Right? So we're happy. This is how you do a function. There are some semantics to this. Okay? I can also define a function this way. I'm going to define show data. The first input is data, and then I'm going to say x equals none, y equals none. Okay? These are the default values for those variables if you don't use them when you call the function. Okay? So now I'm going to print out data, and if x is not none, print it, and if y is not none, then print it. So now when I call these three versions of the function, so show data, sum data is going to print out this 1, 2, 3, 4, 5. But then I can say x equals this inside of the function. You guys see that?
Do you have to say x equals?
You don't. Right? But it allows you to put these in different orders. Right? So the second thing that you can, I could say y equals as the second variable. And I can say x equals at the last right here. Switch them around. If I don't say x equals, then it just assumes the second one is x, and it assumes the third element is y. Right? So this is what I would get. I would get print sum data, and then I would get print sum data with an x value, and then I would get print sum data, and then it prints x and prints y. Okay? So that's function definitions. So if you want to return multiple values, the way that you do that is returning a tuple. Okay? So, and that is the Pythonic way of doing it. Passing things by reference, it's possible that you can kind of do it by using lists and weird manipulations. Not Pythonic. Don't do it that way. That's not considered good Python. You're just going to return a tuple when you need more than one thing to return. So this one would be get square and the 10th power of x. So I'm going to return x times 2. That's going to square it. And x times 10. That's going to take it to the 10th power. Okay? So when I say print this, I'm going to get 4 and 1024. All right?
Can you take the tuples? Sorry, take the values in the tuple and put them in a list easily.
Yes.
Do you iterate through a tuple the same way you iterate through a list?
You can, yes. Essentially, when you get something back right here, I have to relook at this. It might actually be a list when you return it to a variable. Instead of returning a tuple, it might just give you a list. I need to look that back up.
Is x divide 2 the square root? If it's not, then that's sad.
That's a good question. We should try it. After this. All right. If you want to define a class in Python, you can do it. The way that Python works with classes is you use multiple inheritance, right? So you can inherit from lots of different classes. Self will always be passed in. Self is the way that you look at all of your different variables that you have inside of your own class. And that is always passed in as the first argument. And I'll show you what I mean by that. So if I define this class, now when you're defining a class, it is considered Pythonic to have a capital name of the class and then any subsequent words, right? So the exact same thing as Objective-C when you're defining a class, okay? So class body part, object, right here. So I open these parentheses. Essentially what this means is that this class body part inherits from object, the class object, which is a generic class for Python, right?
So you always have to put it there?
No, you don't have to inherit from object. But if you don't, you won't be able to call the super. Okay? If your base class doesn't inherit from object and I inherit from body part and it didn't go, I won't have access to the superclass functions. Okay? So now I could say, okay, I'm gonna have this other class. It's gonna be heart. Oh yeah, sorry. So I'm gonna define different functions with the def keyword, right? So underscore init underscore right there. That will give me my initialization, right? So that is my constructor, right? So if I say self and name, right? This name right here is a variable that someone is going to pass into my class, right? So if I say self.name equals name, now my class has a structure in it, and the variable is name inside of my structure, okay?
Does it make a default constructor if you don't?
Nope.
Are those crazy underscores Pythonic?
Yes. Underscore is considered functions that are meant to be private, but they're not private. But you're telling the user that they're using something that's as more or less private. Okay? So now when I have heart, right, that inherits from body part, I'm going to define my init function, and I'm going to say self, and I'm going to say rate equals 60, units equals minute, right here. So these are the default value for rate and units. So now I'll say self.rate equals rate, self.units equals units, and then I'm going to call the superclass. Super heart self dot init, and I'm going to give it the name right here, which is heart. Okay? We're almost out of time. So then I can define this function called print, where I actually print out the name, the rate, and the units. So now when I actually call this function called I can say my heart equals heart 1 second. That would be 1 beat per second that I'm saying that my heart rate is. Now when I do my heart.print rate, it's going to print my name equals heart has 1 beats per second. Okay? Next time we will pick up on this. We'll finish off the Python. We'll talk about the with statement. We'll talk about debugging, and then we'll go into a couple of really, really quick demos. And then after that, we will go straight into using Python with Tornado and MongoDB. All right. I will. We'll do that Monday. For right now, lab time.